Welcome, Math Models. This is Miss P again, and today we're looking at types of distributions. So we're just going to do a basic overview here of three different types of distributions. We have symmetric, which means it's the same on both sides. We have skewed, which means it kind of leans one way or the other. And we have uniform, which means it's the same all across. So a set of data is skewed if it looks distorted or seems to bend toward one side or the other. So like skewed that way, maybe skewed the other way. Ooh, that's an ugly graph. That's a little better. So skewed, leaning. And you can confirm which way a data set is skewed by comparing its mean, median, and mode. So we've got a diagram here for you that shows you how to tell which is which. So let's start with the symmetric. So this is a symmetrical distribution. The mean, median, and mode are equal. They are all three equal, and it's going to be evenly shaped on both sides. So symmetrical. When you have a symmetrical distribution, the mean is the best number to choose to describe kind of the average. So it's the best for the average. Although, since they're equal, really you could choose any of them. Or any of them. Because they're all the same. Really. And these are our skewed distributions. So if it's left skewed, that's the same as saying it is negatively skewed. So left or negative skew, if that happens, your mean is going to be the smallest of the three measures of central tendency. So you'll have mean, you'll have median in the middle, and then your mode is going to be where most of your responses are. And when this happens, so this happens a lot with salaries, the skewed ones, both skewed ones really. So if you're looking at how much money people make, you might have, let's say athletes. You have most athletes probably not making all that much money, and then you got those few famous ones that make $10 million a year or whatever they make that kind of pull the data out this way. So it happens a lot when you're talking about people's pay. And when this happens, whether it's a negative skew or a positive skew, the best way to describe the center is going to be the median. It's going to be the more accurate way to do it. And then really the only time mode is best is if really this one, because all three are the same, or if your data is categorical. So for instance, if you're looking at something political, maybe you want to see who voted for which candidate, that's categorical, that's a non-number data. Then you might look at the mode for a certain area. Then a uniform distribution is when really all your chances are the same. So all outcomes would have the same probability. A histogram or bar graph of this distribution would have all bars the same height. And our example here is dice roll probabilities. If you're looking at the theoretical probability, all sides have the same chance of coming up. So see if you can think of some other things that might have a uniform distribution where all the outcomes have the same chance of coming up. And that's it for our basic overview of distributions, and thank you for watching.